Okay, good evening, everybody. I do want to talk about what I call a guide to restoring the little things that run the world. And of course, that phrase is not mine. That comes from Edward L. Wilson, extremely famous scientist, myrmecologist, entomologist. He died last year, the day after Christmas, and it was a terrible loss to the world of conservation. But one of the things he wrote was this paper, The Little Things That Run the World, way back in 1987. And his goal was to tell us how important insects were. And his message was very clear. Life as we know it depends on insects. And if they were to disappear, so would most of our flowering plants. And if most of our flowering plants disappeared, that would so drastically change energy flow through our terrestrial ecosystems that the food webs that support most of our animals, the amphibians, the reptiles, the birds, the mammals, those food webs would all collapse and those animals would disappear. The biosphere, the living portion of the earth, would rot because we would have lost insect decomposers that rapidly turn over nutrients. And all we would have is bacteria and fungi. And of course, humans wouldn't survive any of those drastic changes. So it was a somber message, but this was 1987 and nobody really was worried about losing insects. So it largely was ignored. Besides, if we all depend on insects, why do we have National Insect Killing Week? Now, this was 1929, but not much has changed since then. This was a campaign to boost the sales of all brands of chemicals to rid the community of insects. Notice it doesn't say of pest insects or some insects. All insects. All insects are bad. We have to kill them all. Well, even if we succeed in killing all the insects in agriculture, and even if we succeed in killing all the insects at home, we still don't seem to be worried about losing insects because we think they are common in our natural areas. Well, there's a couple of reasons why that is no longer true. One of them is that our natural areas are not big enough anymore. We don't have very many natural areas. We've turned them into our cities, and they, of course, are not designed to support insects. We've turned them into our suburbs, and they're not designed to support anything. Even our rural areas are not designed to support insects. Then, of course, we have agriculture. Let's just talk about rangeland. 770 million acres of rangeland in the US. That's 4.5 times the size of Texas dedicated to cattle, not designed to support insects. In fact, food production on terrestrial Earth now claims about half of the Earth's land surface. And of course, those areas are not designed to support insects either. Another reason that our natural areas are not supporting insects is that they are invaded just about everywhere by plants from other continents. So in the Northeast, it's certainly plants from Asia. This is it's a preserved area called Whiteley Creek State Park near my house. I took this picture in March of a few years ago, and that is when plants from Asia leaf out before plants from North America. So every bit of green you see there is a non-native plant, and they are very poor at supporting insects. So we have non-native plants replacing the native species that insects do depend on, and we've got a lot of non-native plants, about 3,300 species of invasive plants right now in the US. So let's talk about what happens to insects, particularly caterpillars, when non-native plants replace natives. I'm going to share a simple experiment that I did with an undergraduate a few years ago. We simply measured caterpillar populations, both the diversity and abundance, in hedgerows that were invaded with non-natives, like this one, full of autumn olive and multiflora rose and Oriental bittersweet, and on and on and on, and compared it to caterpillar populations in hedgerows that were not invaded. So the trick was finding hedgerows that were not invaded, but we did find some. And what we found is that there was a reduction, 68% reduction in the number of species of caterpillars in the invaded hedgerows, a 91% reduction in the abundance of those caterpillars in those invaded hedgerows, and a 96% reduction in the biomass of those caterpillars, the actual energy that those caterpillars provided to that local food web. And that's why we don't see sites like this anymore. Now, when I was young, if you looked up at a streetlight, that's what you saw. It was just a maze of insects flying around. You don't see that anymore. When you drove down the street in the summertime, your windshield often looked like that, and we don't see that anymore. So that's anecdotal evidence, but it certainly does suggest that insect decline is real, that we are winning our undeclared war against insects. And that's why we're now seeing headlines like this. The insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about global insect decline. We've noticed this first with honeybees, actually several years ago, with colony collapse disorder, and then decided to start measuring what was happening to native bee populations, both in Europe and in the US. So here are a few stats from the US. 50% of our native bee species in the US have disappeared from their historic ranges in the last century. There are 4 species of bumblebees that have declined 96% in the last 20 years. So they're not extinct, but they are functionally extinct. They're no longer common enough to be performing their roles in their ecosystems. There are 3 species of bumblebees that may already be extinct, and 25% of our bumblebee populations are at risk of extinction. In Europe, they've done a better job of measuring insect declines. 30% of Europe's orthopterans, their grasshoppers, katydids, and crickets, are now facing extinction. Some big studies out of Germany a few years ago suggest that there has been a 79% decline in flying insects since 1989. There are 46 species of moths and butterflies that have already disappeared from Germany. And here's the big one. Invertebrate abundance, largely insects, has declined 45% globally since 1974. And that was a 2014 statistic, so it hasn't gotten any better since then. And of course, as insects decline, so do the birds that need them. There are 432 species of North American birds that are now threatened with extinction, according to the State of the Birds report. And it doesn't mean there's only 4 or 5 left of each one. It means that their rate of decline is so steep. That is now that's the metric by which we measure whether extinction is probable or not. They've got to stop declining and actually increase. We've got 3 billion fewer breeding birds today than we had just 50 years ago. That's a study out of the Smithsonian. So that's 1/3 of our North American bird population already gone. How does that relate to insects? Well, we went to the original data set of the Smithsonian group, the Rosenberg et al. Paper, and divided the terrestrial bird species into 2 groups. The species that rely on insects when they're breeding, in other words, the ones that feed insects to their young, versus the species of birds that do not rear their young on insects. So things like finches and doves can actually rear their young on seed. They make milk out of seeds and they feed that to their young. And look, they didn't decline at all in the last 50 years. But the species that rely on insects decline on average 10 million individuals per species. So it doesn't prove cause and effect, but it certainly does suggest that as we take away bird food, we lose the birds. Here's an amazing statistic. Both the house sparrow and the starling, which are serious invasive species all around the world, they are now red listed in Great Britain and England because they have sterilized their landscapes so much. They can't even support their own invasive species. And this is one of the reasons that we see this statistic. The UN now predicts that we're going to lose 1 million species to extinction, probably in the next 20 years. And they actually started saying this about 2 years ago. So now it's the next 18 years. Makes a nice headline, but it is not an option, folks. These 1 million species, and most of them are insects, are what makes the world go round. It's what keeps us alive on planet Earth. So we have to make sure this doesn't happen. So does it matter? Of course it matters. The creatures that keep us alive are disappearing. What if I said to you that introduced plants are reducing your bank account by 96%? I think you would get it right away that that's an issue, that's a problem. Well, insects are the currency in our ecological bank account. And of course, it's our ecological bank account that keeps us alive. So we've got to be alerted to the fact that the insects that are keeping us alive, and we don't even know it, are disappearing at an alarming rate. So I think our only viable option is to figure out how to live in harmony with the natural world, particularly those insects, because that is the natural world that sustains us. In other words, we have to live sustainably with the natural world. So how are we going to do that? Well, I think we should go to private property because most of the land is privately owned. 85.6% of the land east of the Mississippi is privately owned. If we don't practice conservation on private property, we're going to fail. And we can't, of course, fail. We, of course, cannot afford to fail. So what we need to do is start creating ecosystem function by saving insects on properties like this, right where we live. Well, in order to do that, we've got to understand what the causes of insect decline are. David Wagner at the University of Connecticut says insect decline, the causes are, it's like death by 1,000 cuts. There's so many different causes, but here are the major ones. The misuse and overuse of pesticides, habitat loss, we say that for everything, but yeah, you take away the areas that insects need to live and the food that they depend on, and of course they're going to disappear. And that food really depends on particular plants. So our plant choices when we landscape are causes of insect decline. Many of those plant choices result in invasive species that invade natural areas and replace the native plants our insects are supported by. I'm sorry, I can't speak today. So invasive species are a major cause of insect declines. Light pollution is a major cause. And of course, climate change. This actually is good news to me because pesticides, habitat loss, plant choice, security lights, and invasive species are all something that we each can deal with. Individually, we can make big changes about these things right where we live. Climate change, a little harder. There's not much a single person can do to change climate change. Those are going to depend on policy issues, but we can address these pretty easily. So we're going to address insect decline, but which insects should we focus on? There are a lot of insects out there. There are 3 to 4 million species worldwide, estimated because we haven't even described most of them. About 164,000 described species in the US alone. And of course, we're not going to have all those species right where we live. So which one should we focus on? Well, I say we should focus on the two most important insect groups. And I would say that is the insects that maintain plant diversity. Plants, of course, are the first trophic level. They're the organisms capturing energy from the sun and turning it into food and supporting the rest of life on Earth. So plants, pretty important. And then the insects that take that energy from plants and move it up the food web. So what am I talking about? I'm talking about pollinators, particularly bees, and I'm talking about caterpillars. Now, pollinators get a lot of press, a lot of interest in pollinators. Caterpillars, not so much. So we'll talk about both of those. Let's start with pollinators. Why do we need pollinators? Most of you would say, well, they pollinate a third of our crops. 1/3 of every mouthful of food that we eat is dependent on pollinators. Mae Berenbaum, the University of Illinois, actually looked at that statistic and she couldn't figure out where it came from. And her own calculations suggest it's really about 1/12 of our crops depend on insects. You know, the big ones, corn and wheat, are wind pollinated. Soybeans don't depend on insects either. So I don't like that as an explanation. And people say, I don't live next to a farm, so I don't need any pollinators. The real reason we need pollinators is they're pollinating most of the plants that are out there. 80% of all plants and 90% of all flowering plants are pollinated by animals, particularly insects, particularly bees. So losing pollinators is not an option unless we want to lose 80 to 90% of the plants on the planet. I'm not talking about good land stewardship here. We're talking about essential land stewardship. Losing pollinators is not an option. All right, what is a pollinator? A lot of people are confused about that as well. They plant a flowering plant, they see a lot of insects there, and they say, well, I'm helping all the pollinators. There are a lot of insects that are flower visitors, but most flower visitors are not pollinators. They are not actually moving pollen from the male parts of the flowers to the female parts of the flowers. A pollinator is something that actually does that. Now, it doesn't mean that flower visitors are bad. They're part of the diversity that's out there, but they're not doing the job of pollination. Who are our major pollinators? Well, we have one species of honeybee that we brought in from Europe, very important for many of our introduced crops. We got 4,000 species of native bees that did the bulk of the pollination in North America before we brought the honeybee. And we got 14,000 species of moths and butterflies, 2,000 of which aren't even described yet, that are more important in pollination than people think, particularly those moths. They're doing a lot of pollination at night when nobody's looking. So if bees are the most important pollinators out there, and they are, there's a little doubt about that. We have to understand what a bee is. I tell people we need to create native bee habitat right where we live so that we can share our spaces with native bees. And they say, well, no, I'm not going to do that. I don't want to be stung. And I say, oh, they're not going to sting you. Our native bees, most of them are solitary. They're not protecting a hive. You can pet them. when they're at a flower, they won't sting you. And they say, oh no, I was stung last week, so I know that they're bad. Well, I believe that they were stung last week, but it wasn't by a bee. It probably was by a yellow jacket or a honeybee. Honeybees can be pretty aggressive too. So we're not talking about yellow jackets, which are not bees. They are wasps. They are social wasps. They're aggressive. And yes, they hurt. I'm talking about native bees that are not predators. They are going to flowers for pollen. And they really are not very aggressive at all. So how do we make pollinators? Well, we make pollinators the way you'd make anything. You have to give them a place to live and something to eat. So where do native bees nest? Three major places. Ground, we have ground nesters, we've got woody stem nesters, and we have pithy stem nesters. Most of our bees are actually nesting in the ground, about 70% of them. So if you have a piece of ground on your property, you can help native bees, and most of us do have ground. This is a Calides bee in the springtime, a female, well, they're all females that we're seeing. They have sunken a single tunnel down, and then they make little side shafts and pack them with pollen, lay eggs on them, and rear their young down there. So they're very shy. Here she is. She comes up, but as soon as a shadow pops across her head, she'll dive back down in the shadow in the tunnel. So they fly around their hole trying to get oriented before they go down, and people think, oh, they're going to attack me. They're really not aggressive at all. Pithy and woody stem nesters. This is a wonderful picture by Heather Holm that it describes how they nest. They make little chambers inside the stems of goldenrod or hydrangeas, anything where the pith is easily removed. And they will pack it full of pollen, each cell, then they lay an egg on it, and the egg hatches and the larva eats the pollen. That's what a bee larva looks like. Doesn't look like much. You can't even tell where the head is. So this is one cell. This is the oldest cell. The larva is the biggest. It's been eating most of the pollen. Then the bee packed this cell, so it's younger. This larva is not as big. This one's even younger. And they go right on down the line there. When they mature, they pupate in this cell, and then they tunnel out laterally through the side of the stem. So these are the types of stems that you have your native bees nesting in, the pithy stem nesters. And this is a challenge because this is what our meadow plants look like in the wintertime, and people don't like that. They say, oh, it's ugly and we've got to cut them down. Well, it is in these stems that the bees will nest the following summer, in these dead stems. So again, Heather Holm has found that if you cut them off with maybe 15 inches left, you can cut off the tops. Although if you do that in March, because this is seed for our overwintering birds. You don't want to cut that off in the fall before the birds have gotten to eat it. But if you cut it off about 15 inches up, those are the stems that then the following summer the bees will nest in. Woody stem nesters doing exactly the same thing, but they pick wood that is very soft, things like elderberry. So here's an elderberry stem where all the bees have exited after they developed in those cells. But of course, we don't like dead stems, dead sticks on our plants. We prune them off. Everybody knows that's good stewardship, but we're throwing away the resource that our woody stem nesters need. As a matter of fact, we don't leave coarse woody debris anywhere on our property. So we can partially compensate for that by giving them what we call bee hotels. This has become very popular among people, and especially we really love our bee hotels. Some people go crazy with their bee hotels, and the bees do use them. But there is an issue we have to address, and research has shown that when you make large bee hotels and you focus an awful lot of nesting in one place, that makes it very easy for bee predators and bee diseases to find that place and wipe out those bees. So it is much better to have a bunch of small, unimpressive bee hotels, not as much fun for the humans, but much better for the bees, and scatter them around your property the way typical dead woody material would occur naturally. In other words, you're not going to put all your bees in one basket. That's what that amounts to. Okay, what do bees need to reproduce? Well, they need pollen and they need nectar, and they need it all the time. Jared Fowler did a study in New England looking at when native bees were active. Now, this was New England, it's cold. They were active from March all the way to November. Certainly the peak months are May, June, and July, but we had some species of bees out there all the time, which means we need flowering plants out there all the time, or we lose those species. People talk about no mow May. So you don't mow your lawn for the month of May, and a few dandelions and clover will pop up and it'll help some of the bees, and then you mow it again. Well, so any bees that are around in May are going to be killed in June when you mow that lawn. We need no mow places where we never mow them and allow the plants to flower as long as possible. So what species of plants should we use for native bees? This is very important. Sam Droege, Mr. Native Bee, says we need to meet the needs of our bee specialists. We've got about 4,000 species of native bees in this country, and over a third of them.
Hey, Doug.
Yes.
Doug, we're having audio trouble here. So if you could give me 30 seconds, thanks to the folks waiting online.
Okay.
Alrighty. Doug,
What's that?
hear you now. Oh, there we go.
Go ahead.
All good.
All right. Okay, we're talking about meeting the needs of our specialist bees. Over 1,000 species of native bees can only reproduce on the pollen of particular plants. So if you plant those particular plants for the specialists, you're also meeting the needs of the generalists because they can use those plants as well. Why do we have so many specialist bees? Well, the relationship between bees and flowers can be very specialized. The flowers want it to be specialized because they don't want to waste their pollen on bees that are not going to take their pollen to the appropriate species. So that's why our flowers differ so much. Our flowers differ in their phenology, the way they look, the way they smell, the pollen morphology. If you look at pollen grains up close, they've got all these little nungies on them, and those are adapted to grabbing onto the hairs of particular species of bees. They also differ drastically in their nutritional value. Some pollen is actually protected with secondary metabolic compounds to keep other bees from eating them. So all of these differences among flowers create the opportunity for bee specialization so that a particular species of bee will be the best pollinator, move the pollen the most efficiently. And that's what plants want. So you won't have bees like this, Andrena facilii, unless you have Phacelia. That is the only plant, the only pollen that bee can rear its young on. You won't have Andrena asteroides, a specialist on asters, unless you have those asters. You won't have Andrena erigene unless you have spring beauty. So there are lots of plants out there that have specialist pollinators associated with them. False indigo depends on Calides albescens, and we can go on and on. The best plant genera for native bee specialists are these. Sunflowers, particularly perennial sunflowers, are very good. Our asters are very good. Goldenrod's way at the top of the list. Evening primrose. Willows are good not only for specialists, but also because they're blooming so early in the spring. Our early spring bees need forage right away, and it's typically pretty cold, so there are not very many options, and on down the list. There's a new resource. The National Wildlife Federation website has keystone plants by ecoregion, and there's the address for that. And what it does is list the specialist bees that are found in your ecoregion. So you don't have, or the plants that are good for specialist bees in your ecoregion. So you don't have to wonder which plants are good where you live. It's right now written at ecoregion level 1. So that's this huge green area here, which is way too generalized. We're working on getting it to ecoregion level 2, but it still gives you some very good advice on how to choose the right plants for your pollinators. Another important resource now was put out recently by Lorraine Johnson and Sheila Kalla. It's called Garden for the Rusty Patch Bumblebee, but it talks about gardening really for all of the important bees. And it's very good for the more northern states in the Midwest and New England. All right, that's all we're going to say about bees. Let's talk about caterpillars. They are the bread and butter of terrestrial food webs. What do I mean by that? Well, it turns out that caterpillars are transferring more energy from plants to other animals than any other insect. Remember, it's plants that are capturing energy from the sun, turning it into food through photosynthesis. If that energy isn't passed to other animals, you don't have the animals. And most vertebrates do not eat plants directly. Most vertebrates eat insects that eat those plants, and most of those insects are caterpillars. So designing landscapes with caterpillars in them turns out to be really, really important. So how do we increase the number of caterpillars in our yards? Well, you do that by adding the plants that support those caterpillars, which seems pretty easy, but there is a catch, and that is that most plants do not support a lot of caterpillars. So we have to be fussy about which plants we're going to put in our yards if we want to support the most caterpillars. So this is elderberry. It's a great plant for pollinators, a great plant for birds in that it makes very sweet berries during the summer. It is a terrible plant for caterpillars, makes almost no caterpillars at all. So your plant choice does matter in terms of the amount of caterpillars that you can create in your yard. And that's because most caterpillars are highly specialized. Just like those specialist bees, most caterpillars can only eat particular plants. And they became specialists because the plants made them specialized. Plants don't want to be eaten. They want to capture energy from the sun and use it for their own growth and reproduction. So they've loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense. It keeps most of the insects of the world from eating most of the plants of the world. Which is why it's green out there in the summertime. It's not because there's no insects out there, not because there's no caterpillars out there that want to eat those plants. It's because most of the caterpillars that are out there cannot eat most of the plants. They are too well protected. But insects do eat plants. So how do they do that? Well, this is where the specialization comes in. 90% of the insects that eat plants can only eat the particular plants for which they have evolved adaptations that allow them to get around those chemical defenses. Specialized enzymes allow them to store and excrete and detoxify those compounds, behavioral adaptations and life history adaptations that minimize their exposure to those compounds. It takes a long period of evolutionary history with those compounds for all those adaptations to fall into place. And once they do, the insect is locked into eating that particular plant lineage. So if you take the milkweeds, for example, out of your yard and replace them with hostas, the local monarchs are not going to be able to develop on your hostas. The only thing they can develop on is milkweeds. And if you take them away, they have two choices: fly away and find milkweeds someplace else, or starve to death. So it turns out there's three kinds of plants. There are plants that contribute energy to local food webs, plants that do not contribute energy to local food webs, and plants that actively detract energy from local food webs. And obviously we want to focus on these. The very best contributors over most of the country is one of the oak species. They're contributing by far the most energy to local food webs. Ginkgos, Ginkgo biloba from Asia, is a good example of a non-contributor. It's a pretty tree, has good fall color, but nothing eats a ginkgo. It just sits there. So it's not contributing any energy, not supporting any wildlife. And a great example of a detractor would be any of our invasive ornamentals like Callery pear, Bradford pear. It escapes after we plant it, and pretty soon you have nothing but Callery pear. So not only does it not support very many insects, but it pushes out the plants that do, detracts energy from those local food webs. So plant choice matters. If we're going to support insects, and of course that is the goal, we've got to choose the right plants when we landscape, particularly our residential areas. And we've got 135 million acres of residential areas in this country. If we don't choose the right plants, it's not going to work. So for example, if I want to support the Pandora Sphinx, I need to plant Virginia creeper. That is the host plant that'll support that beautiful moth. Same thing with the tulip tree stilt moth, you need tulip tree. Luna moth is a specialist where I live on sweet gum. As you move around the country, it specializes on different things, but sweet gum is its common host. Zebra swallowtail, no matter where you go, only eats pawpaw, only develops on pawpaw. These are all very specialized interactions. 8-spotted forester moth on grape. It turns out that native grapes support a lot of insects, and most of the insects are specialists on those grapes. The green marvel is on viburnum, the brown-hooded owlet on goldenrod. Goldenrod's a great plant for caterpillars, supports 110 species of caterpillars in the mid-Atlantic states. Even poison ivy supports specialist caterpillars, like turns into the beautiful Utilia. And I know you say, I don't want any poison ivy. You know, when you get poison ivy is when you try to get rid of it. Just ignore it and it won't chase you. It'll be good. Sculptured moth on persimmon, the Hebrew on black gum, the fawn sphinx on our poor beleaguered ashes. I think that's beautiful. That's art in the garden right there. Maples are really important plants, support the rosy maple moth. Royal walnut moth on walnut and hickory. This is already extirpated from New England. So we are losing these gorgeous creatures. Double tooth prominent on elm. Witch hazel dagger moth, believe it or not, is on witch hazel. The imperial moth is on pine. Even our native clematis has specialist moth, like the spotted thyrus. Two-toned ancillus on ironwood, lost owlet on buttonbush, the herald on native willows, snowberry clearwing is on coral honeysuckle, our native honeysuckle. The evening primrose moth is on evening primrose. You can find it with its head stuffed in the flowers. Sometimes it's crowded in there, but it's always very cute. Showy emerald on sumac, and I don't mean poison sumac. I've never even seen poison sumac. That's a plant of the swamps. This is things like staghorn sumac and smooth sumac. Great soil stabilizers. We don't need to go to autumn olive and other things to stabilize our native soils. Then we got some really productive plants. I call them keystone plants. Things like native prunus, black cherry will support the white furcula, the crocus geometer, the io moth, the cecropia moth, the colorful zale, the tufted bird dropping moth. Who wouldn't want the tufted bird dropping moth? The paddle caterpillar. Ask your kids to go out and find a paddle caterpillar on black cherry and get them to figure out what those paddles are for. They're not decorations. They're there for a reason. And don't tell them what that reason is. And I'm not going to tell you either. I want you to figure out what it is. It's the same reason that the filament geometer has these expandable filaments on its back. All of these are on black cherry. Small-eyed sphinx on black cherry. Harris is 3 spots. It holds an umbrella worth of its shed head capsules over its head, and if you touch it, it whacks you with it. The showy, snowy shouldered aclaris on black cherry. Then oak is the most productive genus that we have in the entire country, and you get moths like the hag moth, the red wash prominent, the white dotted prominent, the spiny oak moth, the skiff moth, the white blotch heterocampa, the oak skeletonizer, the solitary oak leaf miner, the orange pack smoky moth, the half oval ancillus, the crown slug. These are called slug caterpillars because their head is tucked up underneath, not because they're really slugs. The pink striped oakworm, the spun glass slug, which I think is the coolest caterpillar in all of North America, and literally hundreds more species are found on our oaks.